In this video, we're going to learn how to solve equations. We're going to start with some basic equations, and we'll work our way into multi-step equations. So our essential question is, how does the golden rule of algebra apply to solving equations? The golden rule of algebra is whatever you do to one side, you do to the other. So what it does is it condenses several different properties into one property that we can always remember. Whatever you do to one side of an equation, you do to the other. So we're starting with an example, -16 equals x divided by 3 plus 5. When you solve an equation, you're using order of operations backwards to undo what has been done to the variable so we can isolate it or get it alone. So adding comes after dividing in order of operations, so I'm going to subtract 5 from both sides of the equation. -16 minus 5 is -21, equals the 5 minus 5 cancels. We're left with x divided by 3. To undo our division, we multiply both sides by 3. Again, golden rule, whatever you do to one side, you do to the other. And 3 times -21 is -63. Now remember, on the side with the variable, we're performing the operations to get something to cancel. So make sure that you don't actually perform that operation of multiplication. For example, I get a lot of students that want to multiply the 3 by the x instead of canceling the divided by 3. Every step in solving an equation is done to cancel something. So make sure you're canceling. On this one, we have a grouping symbol. So we're going to cancel the grouping symbol first. We're going to move that -4 in the denominator by multiplying it on both sides. So again, I multiplied by -4 to cancel my -4 in the denominator, leaving me with my numerator of j plus 18. 8 times -4 is -32. And my last step will be to cancel that adding 18 by subtracting it. So then we have j equals -50. Our next topic, we're going to look at some of our variables may have a square. So we're going to look at how to undo that square. So again, order of operations, that adding 8 would come after squaring. So I'm going to cancel that 8 first. Subtracting 8 from both sides, I get 15. To cancel the square, I use the square root. Remember, the square and the square root are inverses, so that'll cancel the square, leaving me with x equals the square root of 15. 15 does not have any perfect square factors, so it's in simplest radical form. This next one, we've got the grouping symbol comes before the square. So I'm actually going to undo the square first on this one. So taking the square root of both sides, the square root of 49 is 7. And then I can cancel that -4 by adding 4 to both sides. So x equals 11. Our final topic is, how do we deal with fractions? So I know a lot of students, when they see fractions, they want to just give up because they think fractions are hard. Instead of giving up, let's get rid of the fractions. And the way to do that is to find the common denominator, or the least common multiple. So 2, 3, and 4 all go into 12. So I'm going to use the golden rule of algebra to multiply everything by 12. So what happens when I multiply my first term by 12? 12 divided by 2 is 6, so I get 6x. Multiplying my 1/3 by 12, 12 divided by 3 is 4, and 4 times 1 is 4. And my 3/4, 12 divided by 4 is 3, times the 3 in the numerator gives me 9. So what I have now is an equation with no fractions that I can solve a lot more easily. So now we're going to cancel the -4 by adding. So we've got 6x equals 13. Then we'll cancel our multiplication by dividing. Again, make sure that you cancel. It's mostly on the multiplying and dividing that I get students wanting to do the work. We're doing this to cancel something. 13 divided by 6 is our fraction. Since 6 does not go into 13 evenly, you can leave it as an improper fraction, or if you would prefer, you can change it to a mixed number. 6 goes into 13 2 whole times with 1 left over, so it would be 2 1/6. I do accept improper fractions, so if you don't want to do the work for that extra step, feel free to just leave it. One more fraction one. The least common multiple on this one, or the common denominator for 5 and 6, is 30. So I'm going to multiply every single term by 30. So my first term, when I multiply it by 30, I get 30 divided by 5 is 6. Multiplying my second term by 30, 30 divided by 6 is 5, times the 5 in the numerator gives me 25. And on the right-hand side, I don't have a fraction, so I have nothing to cancel. 6 times 30 is 180. Now I can set up my solving equation to cancel. So I'm going to subtract 25 from both sides. So the 25 minus 25 cancels, leaving me with 6g. 180 minus 25 is 155. And dividing both sides by 6, I know that 6 does not go into 155 evenly because 155 is not even, and 6 only goes into other even numbers. So I can leave it as an improper fraction. And here we've got a couple of U-tries for you. Please attempt these. Remember how to deal with the fractions. Find that least common multiple and just get rid of the fractions altogether.